Now, good evening, students. Now, today we will discuss the next topic of the real numbers. Now, as we know that the real numbers are a collection of rational and irrational numbers. Rational numbers can be expressed in the form of p by q, where p and q both are integers and q never equals to 0. And both p and q have only one common factor, and that common factor is 1. When we performing their decimal expansion, so decimal expansion of rational number is either terminating or non-terminating recurring. What is a rational number? Rational numbers can be expressed in the form of any number which can be expressed in the form of p by q, where p and q both belongs to integer, q never equals to 0, and both p and q have only one common factor, that is 1. एक ही कॉमन फैक्टर होगा और वो कॉमन फैक्टर क्या होना चाहिए? 1 होना चाहिए. ठीक है. When we perform their decimal expansion, so their decimal expansion is either terminating or non-terminating recurring. Now this can be explained by taking an example. Suppose if I am taking an x is equals to 1 by 5. Now this rational number has a terminating decimal expansion. How can it is proved? Division process करें तो 0 decimal लगाया 10, so this will be 1 by 5 is equals to 0.2. So its decimal expansion is terminating. Okay. Now we are taking one more example. 1 by 3. When we perform decimal expansion of this rational number, so its decimal expansion is 0 for the point lagaya decimal, so 10. So 3 3s are 9, 1. 3 3s are 9, 1. 3 3s are 9. So this 3 will be repeated on. So 1 by 3 is equals to 0.3333. So we can return 0.3 bar. So this rational number has non-terminating recurring decimal expansion. So decimal expansion कैसा हो रहा है? Non-terminating recurring. So the decimal expansion of rational number is terminating or non-terminating recurring. Okay, that is all about the rational numbers. Now in exercise 1.3, basically we have discussed about the irrational numbers. What is irrational numbers? Which cannot be expressed in the form of p by q, and their decimal expansion is non-terminating recurring. First method to decide that number is irrational. So we are performing its decimal expansion, and its decimal expansion is non-terminating, non-repeating or non-recurring. So non-terminating, non-recurring decimal expansion is for irrational number. Now as you know that root 2 is a irrational number, root 3 is a irrational number, root 5 is a irrational number, pi is a irrational number. So how can we prove that root 2 is a irrational number? So two methods are there. First method, we are performing its decimal expansion. So decimal expansion of root 2 is 1.414253 like that. So that is a decimal expansion of root 2. So one method, that given number is irrational, then we are performing its decimal expansion, and if its decimal expansion is non-terminating, non-recurring, then that number is irrational number. Now we discuss the second method that proves that number is irrational. So before discussing the second method is, this method is known as proof by method of contradiction. Method name is method of contradiction. Prove by method of contradiction. So by using this method, we can prove the given number is irrational. But before discussing that method, we discuss a theorem. Theorem 1.3. Theorem 1.3 states that if P divides the A square, then P also divides the A, where P is any prime number and A is any positive rational number or integer. So theorem 1.3 states that if P divides the A square, then P also divides the A. This theorem also used in a method of contradiction. So now we prove that. Question is what? Prove that root 2 is irrational. So what is basically a method of contradiction? First, we suppose that root 2 is a rational number. So if it is a rational number, so it can be represented in the form of P by Q. First we assume that root 2 is a rational number, and after that we prove wrongly that root 2 is not a rational number. So by method of contradiction, first we assume that root 2 is a rational, then after that we also prove that root 2 is a irrational. What we are doing, let's suppose that root 2 is rational number. So if it is a rational number, so it can be expressed in the form of P by Q or A by B. So root 2 is A by B. So 2 is equals to A square upon B square. So A square is equals to 2B square. So by observing this equation 1, what we conclude that A square as a factor 2. So we can say that the 2 divides the A square, then 2 divides the A. That we conclude on the basis of theorem 1.3. By observing this equation 1, हम क्या बोल रहे हैं कि 2 is a one of the factor of A square, because A square is 2B square है. So 2 is a one of the factor of A square. So 2 divides the A square. Then by using the theorem 1.3, 2 is also divides that, because the theorem 1.3 is what? If the P is a prime number, where P divides the A square, then P is also divides the A. So if the 2 divides the A square, then 2 is also divides the A. So here now we taking an assumption that 2 divides the A, then we can say that A is equals to 2C. Let's suppose, because 2 divides the A, then 2 is one of the factor of A. So A is equals to 2C. So A square is equals to A square is equals to 4C square. Now comparing the equation 1 and equation 2, what we doing here, 4C square is equals to 2B square. So B square is equals to 2C square. So this is the equation 3. Now by observing the equation 3, what we conclude that 2 divides the B square, then 2 also divides the B. Now by observing these two statements, the 2 divides the A and 2 divides the B, then both A and B have more one factor as a common factor, and that common factor is 2. But according to the definition of rational number, what we saying that a number is said to be rational if both A and B or both P and Q have only one common factor, and that common factor is only 1. But here, by observing the equation 1 and equation 3, what we are observing here, that both A and B have two common factor, that one is 1 and another is 2. But according to the definition of rational number, that they have only one common factor. So जो हमने स्टार्टिंग में जो assumption लिया था कि that root 2 is a rational number, that assumption is proved wrong. So this is called method of contradiction, and by concluding these two statements, now we conclude that root 2 is a irrational number. So that is a method of contradiction. Firstly, taking a statement which we proved wrong, and that's why this method is known as method of contradiction. मतलब पहले हम एक statement ले रहे हैं, अपनी तरफ से एक statement assume कर रहे हैं, फिर उसी statement को हम wrong proof कर रहे हैं. That's why this method is known as method of contradiction. Similarly, by using this method, we can also prove root 3 is a irrational number. So same approach is there. Now let's suppose that root 3 is a rational number. So root 3 can be expressed in the form of a by b. So squaring both the side, so 3 is equals to a square upon b square. So a square is equals to 3b square. So 3 divides the a square, then 3 divides the a according to the theorem 1.3. So from this statement we also say that a is equals to 3c. So a square is equals to 9c square. Now comparing the equation 1, 9c square is equals to 3b square. So b square is equals to 3c square. Now by observing the equation 1 and equation 3, what we conclude that 3 divides the a square, then 3 also divides the b square, then 3 also divides the b. So from these two statements, what we conclude that 3 is also a common factor for both a and b. But according to the definition of rational number, they have only one common factor, that is 1. But here in the situation, both a and b have two common factors. One is 1 and another is 3. So it is not a rational number. If it is not a rational number, then it is a irrational number. So that is a way to prove a number irrational. That method is known as method of contradiction. Now next question. Same, we have used a method of contradiction. Prove 5 minus root 3 is irrational. Again we are using a method of contradiction. Let's suppose 5 minus root 3 is a rational number. 5 minus root 3 is a rational number. So 5 minus root 3, this can be expressed in the form of a by b. So 5 minus a by b is equals to root 3. Now this 5 minus a b is a rational, because 5 is an integer, 5 by 1 is a rational, and a by b is a rational. So overall 5 minus a minus b means subtraction of these two rational numbers is a rational number. But before example where we prove that root 3 is irrational, so here root 3 is irrational, that we already proved. So ये जो equation है कि 5 minus ab is equals to root 3, it is not true, because 5 minus ab is rational and root 3 is irrational, and rational and irrational number are not equal. So from that we conclude that 5 minus root 3 is irrational number. Why we are saying that? Because 5 minus a by b is irrational, So a rational number never equals to irrational number. So we can say that 5 minus root 3 is not a rational number, it is a irrational number. Is that clear? Now one more example which is related, which is also based on this method. Question: prove 3 root 2 is a irrational. Okay? Again we are saying that, let's suppose that 3 root 2 is a rational. So 3 root 2 can be expressed as a by b. So now root 2 is equals to a by 3b. Now a by 3b is a rational number, but root 2 is an irrational number, that we already proved in the question 1. So one rational number is not equals to one irrational number. So by method of contradiction we prove that 3 root 2 is a irrational number. मतलब मेथड ऑफ कॉन्ट्राडिक्शन क्या है कि जो स्टेटमेंट हम पहले सपोज कर रहे हैं कि दैट स्टेटमेंट इज ट्रू, वही स्टेटमेंट हम बाद में मैथमेटिकली रॉन्ग प्रूफ कर रहे हैं. दैट्स व्हाई दिस मेथड इज नेम्ड एज मेथड ऑफ कॉन्ट्राडिक्शन. दैट इज ऑल अबाउट द एक्सरसाइज 1.3. एक्सरसाइज 1.3 में इसी वैरायटी के क्वेश्चंस आपको दिए गए हैं, तो यू जस्ट ट्राई दैट क्वेश्चंस. ओके.